And we're live. Well, thank you so much, Alex, for coming. Let's start with a quick intro. I'm Griff Green. I'm trying to research scaling for Giveth. And Alex?
I'm Alex Miller. I work for a company called Grid Plus. I'm a co-founder, and I do all the Ethereum stuff. I've been an Ethereum developer for a couple of years now. And
Nice.
Thanks for doing these. And thanks for having me.
For sure. Hey, this is a pretty badly needed thing in the space right now. Everyone's kind of running into it. And I should say that this is the 4th interview, so if you want to see some other ones, there are lots of people. So far, we've only been doing bridges and bridge chains, but there's lots of interviews with Parity, POA Network, and Truebit before this. And all of this is going to culminate in a meeting in Barcelona, which I hope someone from Grid Plus can show up for. Probably you. To help other dApps walk through how they could implement this solution. That'll be March 6th in Barcelona, so save the date and reach out to me if you want to come. Okay. Let's see. So obviously you're doing a lot with Grid Plus. Grid Plus is a really cool project, and I think we'll get into that a little bit, but the main purpose of this interview is to take a deep dive into your relay solution. I want to start saying that this audience is assumed to be really technical-minded devs that work in the Ethereum space. They have a dApp right now, and they're already considering using a sidechain as part of their strategy, and they want to launch ASAP, at least in the next 3 to 6 months. And they might not understand everything that you talk about, especially your solution is super technical. So we might need to go into the infrastructure a little bit, but these guys aren't rookies. They know they'll know what you're talking about, right? So, dude, your blog posts, you have some of the best documentation out there. Your blog posts, your GitHub, it's really beautiful. So that should make everything easier for people to reference. But and even I was actually reading it to my girlfriend to explain Merkle trees, and she got it, so well done, first off.
Thanks. Yeah, we put an emphasis on documentation over at Grid Plus.
Oh, you can tell, man. It's really good. But I'm going to assume that most people haven't read that. Can you just kind of explain your relay solution, especially focusing on the different actors in the system?
Yeah.
And I read it, so I love how you compare it to Sharding, and if you can bring that into the explanation too, that would be really cool.
So before I do that, just want to give background on where it came from. So Grid Plus is building a piece of software that would allow you to buy and sell electricity on a battery. And we were going to do that with just payment channels, vanilla payment channels over the mainnet. And that seemed like a viable solution until CryptoKitties kind of took over the network. And we realized that Ethereum is not going to be cheap, probably ever again. Sharding will alleviate the cost a little bit, probably a considerable amount, but the victim of its own success as it gets more applications and users. Ethereum, just goes up in the cost of transfer. So we've been kicking this idea around for a while, actually, of sort of like app-specific sidechains and some way to bridge them. We hadn't gotten into the technicals, but that was sort of this high-level idea we had. So I started running with it, and the initial thought was to do a trusted relay. So there would be an intermediary who would kind of control two sides of this relay between these two chains, and they would just forward transactions. I realized that there was a way to do it without requiring that centralized actor. And I realized actually that the assumptions I'd made about the safety were false, as pointed out to me on Reddit. So kind of trashed that design, went back to the drawing board.
Wait, what was wrong with the safety?
So this was pointed out by Jeff Coleman, who is working on generalized state channels. What I was kind of assuming was that you could deposit into one side of the bridge, and because you had signed some message, the relayer, the centralized relayer, would not be able to steal your money, right? Because they would have to replay that message, and it would have to go to you. But he pointed out that the relayer could just spin up a bunch of fake accounts and not actually deposit money and just like spoof these signatures. So, you know, it's good. I mean, it's good to have flaws pointed out early, and it led to a much better design, in my opinion. So, what we're doing now is we call it a trustless bridge. So we've been going back and forth between relay and bridge. We don't really know what to call them. I like bridge, so we're gonna go with bridge. So what you have is 2 smart contracts, one on each chain, and you have a set of stakers. So when I say this set of stakers, that's pertaining to one of those contracts, and it's a symmetrical system, so you'd have the same thing on one side as the other, with different, amounts of value depending on probably which chain it's on. So there's this set of people who have staked a given token or ether, whatever, into the bridge contract, and similar to the way, actually pretty much exactly the way that Sharding does it, there's a proposer that is selected pseudo-randomly based on a block hash. So basically, you take the sum of the stake, the total sum of stake, and you use that as the modulator for the unsigned integer of the block hash. So it's some huge number, like unbelievably big, and you mod that with the sum of stake, and then you get some slice on this like continuum of stakes that people put down, and that selects a validator with probability proportional basically to the size of their stake. So once you have your proposer, that actor is able to play data onto the bridge. And once that data has been signed by a validator threshold, so that's of the other stakers, so some number of stakers have to sign off on the data. It passes through, it gets written to the state, and the bridge continues, basically. So that piece of data in kind of a naive system would just be the block header of the other chains, like the last block header. But we realized pretty quickly that that's not feasible from a gas standpoint. So if you have a side chain that runs every 5 seconds, then first of all, it's not possible to bridge that to the mainnet. Second of all, even if you could, you're looking at 3 transactions every 15 seconds, which is not going to work. Yeah. So what we have is a system where what the proposer is actually playing is a Merkle root of a set of block hashes. So if you have a side chain, it's running maybe like 1,000 blocks elapse. The proposer packages those up into a Merkle root, puts that on the relay contract, the bridge contract, and anyone who had deposited on that other chain within that block range can then basically prove that they did that in another like set of steps. But they have the ability to do that once the proposer has basically settled that range of blocks. So the cool thing about that is you get a much longer settlement time, but it's also a lot cheaper, so it's more economic. And the settlement time is actually dynamic. So you can parameterize the bridge to issue a reward, and that reward is a function of the number of blocks that have elapsed. So, and there's a cutoff. So if the proposer waits too long, then other people can take over. And as long as they have the right number of signatures, they can actually earn that reward. So that's kind of it in a nutshell. It's pretty technical, as you said.
I already got some questions for you. Just
shoot.
On that point, when you say that it's dynamic, does that mean dynamic per dApp, or is it just like the code is dynamic? Once you set the parameters, then it's that way forever, or is it slowly going to change?
What I mean is that if you're bridging a chain and 128 blocks go by, and the proposer says, "Okay, that's good enough for me," he sees the reward. So there's a reward pool, and you get a reward for proposing. And that reward is a function of the number of blocks that go by, and it grows as more blocks go by. So if one proposer is okay with 128, He checkpoints that. That's fine. Another proposer is chosen, but that one's a little pickier. They actually want it to wait 512 blocks because they want the bigger reward. And they're willing to wait. So they wait 512. That's fine too. So the first one was 128. Next one 512. It doesn't matter because it's dynamic. You just say what the end block is, and it's assumed that the start block was the one after the previous end block, and that's fine. So it's
what stops someone from saying I'm going to wait 2 million blocks?
Yeah, so there's a cutoff after, and that's just a parameter of the system. So maybe it's 1,000. So if the proposer waits past 1,000, then anyone can step in, and anyone who has staked. Anyone can step in with the right number of signatures, and they can get the reward themselves.
And is this like, let's say I want to bridge to Rinkeby? Well, that's kind of the concept for this this call. Would there be one bridge for my DApp, and if someone else wanted to bridge to Rinkeby, they would use another bridge, or would there?
No. So you think of a bridge, and a bridge has you can think of it as like a one-to-many bridge. So you have a contract on the mainnet, and that will bridge any number of blockchains. And those are the chains themselves. So you just take in header data from these other chains, and you can bridge them going that way. But since it's a symmetric system, you would need the same thing on Rinkeby. So there's two bridges. I mean, it's kind of the same thing, together they make a bridge, or however you want to think about it. But basically, it's a many-to-many system.
Okay.
And at a basic level, you would have one on Rinkeby, one on mainnet, and all of the Rinkeby data would go to mainnet. All of the mainnet data would go to Rinkeby.
Okay. And is there a option for 51% attack on this, or not really? Right.
Yeah, in the same way that there is for proof of stake. So I'm not a social consensus engineer, nor do I wish to be. So we will be using basically whatever the EF puts out for proof of stake. So so actually this is pretty deeply inspired by Sharding. Sharding also does a staking system. They also relay data kind of between the shards. But a lot of that setup is basically just forked in this model. So certainly the consensus is.
Okay. Yeah, I mean, it sounds just like Sharding, the many. It sounds like you're using the validator manager contract, basically.
Yeah, that's very similar to what it is.
Yeah. What are the specific differences?
So I need to go back and read the Sharding doc. I'm not like a super expert in it, but obviously the biggest difference would be that you can bridge any number of chains that are third party. So it doesn't need to be subsumed into the mainnet. And with Sharding, you're still going to grow the state. So there's a global state, I believe. And you're still, well, I don't know, actually, is there?
I think there's a global state. And I think that there's definitely different account spaces, or the same account spaces in different shards. So in that way, I think it's similar.
Yeah, there's different account spaces. I'm just wondering if on the mainnet with Sharding, someone will have to maintain, like an archive nib will have to maintain the entire state. I'm not sure if they will. I kind of assume they would, but I don't know.
I would think there are definitely applications that would want to, like Etherscan, for instance.
Yeah,
is going to need to hold it all. So.
But anyway, it's basically like a third-party sharding for any type of chain, proof of stake, proof of work, proof of authority, application specific, gambling chain, whatever. So, all of those scaling solutions to this point they're very exciting, but they're all kind of driven by the foundation in some way. And I like this wave of like bridges because it seems like a community effort, which is super cool. And I think we're going to it also allows you to like iterate faster because you're using these kind of battle-hardened tools that are probably the hardest part, right? So like the blockchains themselves, the consensus engineering that went into blockchains, and you're using those as sort of like building blocks for bigger networks. So
yeah, I think it's pretty cool too. Many hands make light work, you know. So if we have, I know Swarm City and Parity are working on a solution. POA Network is taking Parities and running with it. I'm excited to see other people start taking your solutions and, you know, Truebit's solution and the other bridge solutions, and, you know, start having these little groups that all compete to make the best thing. And then what do you know? Someone will just win, and they'll have 90% of the bridge contracts will be working right there.
It'll be fun. So I have no ego about it. If this is not the best solution, then that's fine. But I think that in this space, we get a little carried away with visions of the future and make the assumption that like this one thing that's been marketed really well is going to capture all of the market share for this problem that it hasn't even, you know, begun to solve because it doesn't exist yet. So yeah. I will enjoy seeing several of these on the market soon.
So what's the incentive structure? What makes the proposers, you know, obviously they get a bounty when they propose their blocks. Where does that bounty come from? Why do the actors act in your system?
Yeah, so there's a couple ways. The first is if someone wants to bootstrap a bridge, they can pay into this bounty pool. So there's a pool where all of the bounties come from, or proposal awards, or whatever you want to call them.
On each chain.
And so the question is, who pays into that pool? So the first would be someone who wants to bootstrap it. The second would be if someone wants a one-use pass, basically. So you can allow these bridges to whitelist participants if you want. So if you want to make them pay for it, they pay a fee that will cover like gas costs or something, and probably a little bit more because it's a one-time fee. And they do that, and they can make their deposit, and then the withdrawal is free. And the user pays the withdrawal because they have to do the proof. Mm-hmm. So that's one way. The other way would be, the other way that I actually think is cooler is a subscription fee. So we don't have any crypto systems with subscription fees, but you can imagine paying like a couple bucks a year, and you know, like the average cost to a relayer is probably not going to be that high because it's a settlement layer, so you're not going to use it all that often. And I can imagine, you know, a yearly subscription fee where you remain on the wait list. So that's really interesting. We'll see where those models come from. I think for a while they'll just be subsidized, and that's fine. But I'm pretty excited to see if they can be, you know, like profitable systems, because they're really just collections of people or machines. We can get to that in a little bit, but collections of actors who want to earn some revenue for their bandwidth, basically, and their stake, so their cost of money.
And so, does it matter if you're using Geth or Parity or any of that?
No, it shouldn't. So the tests were done in Parity. They actually treat signatures a little bit differently, but the contracts handle those. So there's EIP 155 that changed the V value in EC signatures. But in the client itself, like the only thing that matters is you're basically just using an RPC endpoint. So
very cool. And if, for instance, on testnet, the token of deposit obviously can't be testnet Ether. Could you modify the contracts to use a token as opposed to the mainnet like native currency?
So actually, right now they're only designed for tokens.
Oh.
I could add Ether, and I just haven't gotten around to it. But they're ERC20 to ERC20. So yeah, let me talk actually a bit about how the assets are transferred. So one of the things that distinguishes a bridge, really the only thing that distinguishes a bridge between an atomic swap And this is something that actually a lot of people get confused because they haven't really thought to define find enough detail, but there is like a subtle difference between these things. So with an atomic swap, basically you are your counterparty. So like you are locking up tokens in one chain and you're releasing them in another chain. Or sorry, you're not your counterparty, you have a counterparty. So like you put something in a box, you give them the key, they put something in the box, they give you the key, you both can unlock their respective boxes. And so that's an atomic swap. And people have been talking about doing those with like Bitcoin and Litecoin. And that's cool, but it's, it's trading, right? So you have to have a counterparty. So what you want is to move tokens into another chain that belong to you and will always belong to you. So what you basically have to do, I've found, is that you have to replicate them somehow. So the way that it works in the bridges we're building is that right now we have an admin. Although I've actually thought about this, and I'm not sure it needs to be an admin or anything. I think anyone can do this. But basically, they call a contract, call a function on the bridge contract, and that creates a token that then maps to the token on the other bridge. So if, for instance, on the mainnet, you have a token that starts with AB, you call this function on the side chain with the AB parameter. It creates a token. It moves all of those tokens to the bridge, and it maps them to AB. And the number of tokens, and the name of the token, the symbol are all identical. So you basically are replaying the transaction that was used to create the initial token. So it's really important to have these things map one-to-one, because if your accounting goes off, you have big problems. But it shouldn't, as long as all those tokens are moved to the bridge contract initially.
Okay, so you're really, it's just like a teleportation device. You send it in, and then it comes up here. You have it on both sides. Boom. Yeah. Okay, and only ERC20 tokens. That's really interesting. I take it that's because you are designing this for Grid Plus, right? Yeah. Can you explain how you guys expect to use it?
Yeah. So as I mentioned, we realized that we aren't going to pay $20 to open and close the state channel every month. So we'll be using a sidechain. I don't know if it'll be our own or if we'll use a common one, but regardless, we'll be using a sidechain, which means bridges. So we're building them. One of the reasons we're building them, one of the reasons we like this idea so much, is that we have these devices called agents. And we want these to be the rails of the crypto ecosystem. So at a basic level, they are, you can think of a ledger. So a ledger has a secure signing chip, and that's different than the chip that actually runs the program that you see when you boot up your computer or when you plug it into your computer. So if you take that concept, and the reason it's secure is that the keys never leave your secure signing chip. So we basically extend that idea to a much bigger general computer and put it on an IoT device. So what this allows us to do is run applications on a hardware wallet. So you have access to funds, but they're secure. They're secure in the same way that your ledger is secure, right? So keys are never going to leave your chip. You can set up permissions, actually, to require physical PIN entry if a transaction amount exceeds some threshold. And other than that, you can do remote signing. So if it's for a tiny amount of money, or if you just need a signature that isn't on like a transaction to move Ether, it can do that for you if the GCU says that it's okay, basically. So what this allows us to do.
What's a GCU?
Sorry, General Compute Unit. Okay. Yeah, I've been talking to our head of hardware too much lately.
Okay, no worries.
So what this lets us do is create applications that run on this IoT device. And we really want to build the app store for crypto. So what we want in this app store are basically apps that will earn the users money. to like give people a reason to buy these things, and show them some value, show that they can earn some value from basically having it on and staking their money away. So we're gonna be seeing a lot of staking apps, and this will probably be the first one. So we will have official Grid Plus bridges, and those will run on agents. The bridge software is open source, MIT license, so anyone can create their own bridge networks, but we are going to have specific agent ones, and those will be to run the relay for whatever chain we're using. And we may do others, but certainly that first one. So those will stake Grid, which is our token, and those will basically require an agent. So there will be like a whitelisted group of agents. But we're also building this software open source, and I hope that there are other bridges as well. We don't want the agents to rule the world entirely.
Yeah. Yeah. There's a lot of cool projects doing these kind of like decentralized deployments of hardware. I know, obviously, I work for Slockit. We were trying to do it with the Ethereum computer. We had a plan to do that. Swarm City has something very similar. And actually, Jordy's doing a decentralized personal server idea where you can run IPFS, Monero node, Ethereum node, and kind of click it. It'd be really interesting.
What's that project that's been going on forever? Urbit or something?
Urbit? Oh, I don't know that one.
Urbit. Yeah, so Urbit, that was the whole idea. It's like 10 years old, but and they're still working on it, which is amazing. But yeah, they created like this whole language, and the idea was that there was a different container computer for every person, and there was like a private key, and you could do cryptographic operations and stuff. But you could like store it in the cloud safely because you knew the key to get it unlocked. But yeah.
Wow, that's really interesting. I'll have to really look into that. I don't know that Jordy has seen that, so we'll have to definitely dive in. We're doing this for Catalonia, but I don't need to get into that. It's off topic. So, okay, are there any points of centralization? It sounds like you have this admin guy, which you're hoping to move out. Are there any other points of centralization in the system?
Yeah, so the admin could absolutely be replaced by consensus. The point of centralization is social consensus. So when I first started this, I looked at doing basically relaying proof of work block headers, and it was kind of infeasible because you needed, so with Bitcoin, when you have a block header, you can tell the difficulty right away because it's the number of leading zeros. But with Ethereum, it's different. You have to basically run it through this huge like 3 GB DAG, which like you can't do in Solidity. So that was kind of a non-starter. And I realized, that's okay. I'll do it with Casper. We're going to Casper. That's fine. But then I thought about it and I was like, well, BTC Relay, which was kind of the predecessor for all these things, had this cool like difficulty tracker. So you could tell how much work had been put into this probabilistically. And Casper doesn't have anything like that. So basically to replicate social consensus, I realized like kind of need to, to get anything out of social consensus or to extend it, you need to basically replicate it. So to whatever extent that's centralized, that would be the centralization point of the system. But it'll be interesting to see how that kind of pans out. I think like my personal opinion is that we can't go anywhere without proof of stake. We can't depend on proof of work to run these systems at scale. Yeah,
couldn't agree more. And on the points of centralization, though, it sounds like to start out, it'll probably end up being like, some dApp that will kickstart it, start their bridge on whatever chain they're going for. And so they'll have all the stake and they'll be the main one. And then slowly people will come in. Does that sound like
probably. Yeah. So for the chain that we would, or for the bridge that we would run with the grid, it would be like the biggest grid holders would potentially, be the biggest points of centralization. And that would be true for any token that you would stake.
Oh, well, that's an interesting point too. Yeah. So, because there's grid holders and then there's grid holders that actually would send it into the relay, right?
Yeah.
And people have to, I mean, you're not going to automatically put grid into the relay contract or anything like that, right? It's always going to be someone decides to support.
Yeah, someone has to decide. Yeah.
Okay. Okay. Well, what's the current status of the project?
It's in development. So the trustless version is not that old. It's maybe a month old. I finished the contracts pretty quickly. That's not true. It takes a while. I finished them when I did, and I'm working on the client now. So it's good, running with it, going as hard as I can. I want to get this done in the next couple months, but we'll see.
You're a one-man show over there, man.
Yeah. So I am the Ethereum team at Crustless. So we have to do this energy stuff. Because that's like the core of our business. But I wanted to. So my idea for this agent is, we're doing the energy stuff, and you will be able to buy and sell electricity with your agent, which is great. But we can only operate in Texas to start, and that whole time frame is law. So if that was the only thing we were doing, then the only people who'd be able to use agents are people in Texas. And I like Texas. Like I live in Austin. But I think there's a world full of crypto fans who would love to stake for bridges with their agents. So we want to build up this app store that will appeal to people all over the world who like crypto, who want to earn money, basically, so that we can get the agents, other places. So that's kind of my mission, is to build cool stuff for the agent, which is sweet.
Yeah, dude, app devs have the best jobs, right? It's like, it's pretty fun. So it sounds like you have the smart contracts pretty much done, but they need to be audited or something like that, right?
Oh yeah. They're version 1. I would not trust them with large amounts of money. So I do think that we could spin up a bridge pretty quickly, and we can maybe limit the amount of stake, or just like tell people, don't stake a bunch, please. Your money's at risk. But I would not put this into like heavy production system until it's been audited. And it's a big contract, so it could take a while. But my plan is to run it as quickly as possible. So expect a beta test like as soon as all the stuff is built.
And you're working on the client, and the client is like, it's necessary to launch the bridge, isn't it?
Yeah. So the client is the scope of the client's bigger than just the contract. So I started that like last week. So the scope isn't tremendous, so it won't take that long, but it's hard to estimate how long it'll take. But my projection at the moment is probably like 2 or 3 months.
Oh, not bad. And do you have are you going to target Rinkeby by chance?
Yeah, we could.
As your first?
Yeah.
Oh, that would be nice.
I don't really care. So whatever there's demand for. So if you want Rinkeby, we can do that.
Yeah. Well, what can people do to help?
They can apply for a job at careers@gridplus.io and come build bridges with me. So we'll also, if they want to look at the contracts, actually, if they want to audit them, then that would be very helpful. Or just like look them through. More eyes is always better. So just check them out. And if they want to make improvements, they're welcome to submit pull requests. There will be some bounties on Gitcoin that will be coming out probably around ETH Denver. That will be contract specific. That's it. Yeah.
Okay. That sounds pretty cool. Do you have a place where people can find you, or what's the best way for people to actually ask you questions about this stuff?
Yeah. So for now, I recommend the Grid+ Telegram, Twitter as well. So I'm always on Twitter, either me or the Grid+ Twitter. Do you have those linked on this video?
Yeah, you're
Okay.
at Ethereum_Alex, right?
Yeah. And Grid Plus is at Grid Plus _energy. Our Telegram group, I can't remember what it is. If you go to gridplus.io, there's like a Telegram thing. So just go join that. I pop in and out. I'm not there all day, but if you have burning questions, please post them and tag me. Tag me with @EthereumAlex. But yeah, once the software is more built out, I'd like to get a like a Riot room or something for the bridges themselves.
I was going to close it, but there's two things. Number one, if anyone has any questions, definitely ask them in the chat, because there's at least 10 people watching this right now, so you never know. Someone might have some better questions than me, and probably. And then I forgot to ask you about you have this idea for a front end facing dApp, right? That goes around this bridge.
Yeah. So there needs to be some interface. My idea is just a React app that I haven't started yet, but it will basically, you are on some network and you want to move to some other network, and you have some tokens, and you press a button and like sign a transaction, and that basically deposits it. And then you go to that other network and say which network you're coming from, or it can store that in your browser. And there's like a withdraw button, and that's basically it. But behind the scenes, it like interacts with the contracts and stuff. And ideally, I'd like that to be sort of like an SDK, so dApps could integrate that into their own websites. They wouldn't have to leave and like go on gridplus.io, because I know applications like keeping their users on their websites, which is fine. So that stuff would be coming after the client's done. So keep an eye out. Keep an eye on the Grid Plus GitHub, so github.com/gridplus, and I'll tweet about this and stuff. So
very cool. Yeah, I mean, there's a lot of good front-facing dApps that have done something similar to this. I mean, not with 2 chains, but MakerDAO migrated from old coins to new coins. Same with Swarm City. They started out as Arcade City tokens and moved them to Swarm City tokens. So I think that you'll be able to find someone to help you out with that. I just realized I have a bunch of awesome questions. Coin Hodl says, how many transactions per second can these different relay and sidechains, proof of authority, etc., actually pull off? I know Igor's POA network gets 60 transactions per second. Is it the same with what you guys are looking at?
So that would be Sidechain specific. I don't know. Yeah, POA can probably do 50-ish. That sounds about right. For like relaying the number of transactions, it's like whatever the sidechain is. So again, you relay one piece of data, which is a hash, and that can represent the last 1,000 blocks of the sidechain or 10,000 blocks. It doesn't matter. So as fast as the sidechain wants to run, you want to run your sidechain at 1 block per second. That's fine. You can relay a Merkle root with 100,000 headers in it if you want, and pack that down to 1. So your users' withdrawal will be a little bit more expensive, but the cool thing about Merkle proofs is that they're exponentially, or their cost only grows on a log scale. So the difference between 1,000 and 10,000 gas-wise, do like another hash in Solidity is not that big a deal.
Yeah, which is really cool. And your blog post explains that so well. Again, like your documentation is so good. So I really hope people take advantage of it.
Those pictures.
Yeah, the pretty pictures, man, and little charts that just say, "Oh yeah, this much for this many transactions." Yeah, I mean, it's so nice.
Yeah, I like measuring gas costs. That's something I enjoy doing.
That's kind of the name of the game. Like that's why we're all here. So, and on, okay, I'll ask this one. Will agents be able to simultaneously? This is Huxtable sweaters, by the way. Will agents be able to simultaneously stake for Casper, Grid Plus, and other dApp sidechains using your relay network code contracts?
So I think the question is, so they know they can stake for bridges. Will they also be able to stake for Casper? I don't know. So the problem with Casper is that it looks like we're probably going to need a full node, and I don't know if we can pack a full node onto the agent. Believe me, we will look into it once Casper is released. We would love to get it on there, but the short answer is I'm not sure.
Maybe you have two scales, you know, the Grid Plus agent and the Grid Plus agent Casper or Super.
That's actually something we thought of. That's a possibility, but it's you'd have to convince my hardware guy. So.
Yeah, for sure. And then actually, I can't believe I forgot to ask this. How many transactions does it take to do the process, right? So you start with
good
depositing
question.
and withdrawing.
Yeah, so it's terrible. It takes 1 to deposit, which is obviously that's cheap. Right now it takes 3 to withdraw, which is terrible. But the total gas, I believe, is under $500,000, so it's not super expensive. But so this is something someone could help with. I just didn't slice up the bytes efficiently enough, and I packed too many variables into these function names, so the stack overflowed. So I just split it into 3. It was like whatever. So the idea is for version 2 would be to get that down to at least 2. I could definitely do 2, and hopefully 1 for withdrawals.
Okay.
Yeah.
Okay. Huxtable Sweaters asks, are you looking at Casper or taking your own approach? I assume he means for like these contracts and consensus.
Yeah, so it would actually be off of the Sharding one. So I believe Sharding also uses Casper. Yeah, we're not going to design our own consensus system.
Good.
That would be silly.
Oh, and also from Huxtable Sweaters, what examples are you looking to for a fee structure that would incentivize staking but not impose a noticeable burden on retail electricity users?
So for electricity stuff, they'll probably start off on the sidechain. So they probably won't touch the mainnet. And if someone wants to move their tokens on there, they can do that. If we have the bridge on the agents, and our customers want to, like move Ether to the sidechain so they can buy electricity from us, we'll pay for them. Use the bridge because it will be pretty small.
Yeah. Mark Booth asks the taboo question that you should never ask a dev, but I'll ask it anyway. Target date for beta testers in Texas to get Smart Agent and begin using Grid.
So this is outside my purview because I'm actually not working on this, but I think the end of the year is our target to get our first beta testers.
Okay.
So we have the retailer. We're working on the agent. So one of our offices looks like a machine shop, which is pretty cool. And we are integrating with the upstream providers. So we're working on it. So the slowest part is going to be regulatory stuff.
Yeah, I mean, this is the thing, you never know what can go wrong. There's so many little pieces, and you expect, oh yeah, we'll get that done in a week. Takes a year sometimes, problems arise.
We would love to have it done as quickly as possible, but realistically, probably the end of the year for the first tranche.
Yeah.
And those will be like probably 100 people in Texas. So yeah, if there are people in Texas, I don't know if we have a sign up yet, but we will soon if we don't. But sign up, and if you're in particularly Houston or Dallas, you should be able to get on the beta list.
Very cool. Very cool. And will you just send them agents? Like, here's your agent, go for it?
Yeah, we haven't worked it out yet. Maybe. You might have to buy them. I don't know. I'm not going to make promises that you won't have to buy the agents, but you probably will just send them to you.
Yeah. Well, this was such a cool talk, man. Thank you so much for taking the time and hanging out and giving us the deep dive into your system. It's really cool. I hope that somebody watches this and ends up diving in and being really productive with you, because I really like what you're working on, and I think it's a really important part part of this ecosystem. We need more decentralized bridges. So
yeah, and so I think I know Parity is working on the like a trusted version, but it'll be interesting to see like what is a more efficient system. I don't know actually. So the one that I had before where you had to play each message, I was like, that was super inefficient. But the way they do it might be a little bit more efficient. So it'll be interesting to see both of those on the marketplace and if there's a demand for the more decentralized one.
Yeah.
And I'm sure there'll be demand for being a proposer, which will be cool.
Yeah. Hey, everyone loves running hardware and making money.
And making money,
cool.
yeah.
That's just fun.
That little box, just like I have like a Raspberry Pi by my desk, and you know, if that thing was just like making me money while I was typing on my computer, that'd be great.
Yeah, that's just so cool.
What we should do is have like a cha-ching, you know, like play on the agent.
Yeah.
Have a cash sign on the touchpad whenever you get selected as a proposer.
Oh yeah, I mean, there's so much fun we can have with this stuff. So, yeah. Well, again, dude, thank you so much for your time. And just say one more time, Twitter and all that contact information.
Yeah, at Ethereum_Alex on Twitter, and then you can join the Grid Plus Telegram. Go on gridplus.io and click on the Telegram button.
Okay, I'll try to put some links to it below. Also, we have a Scaling Now general chat on Riot. So if you guys want to dive into that, or anyone who's watching wants to see people talking about the scaling issues that people are working on, I saw Swarm City is basically developing with Parity a solution, and it's just cool to watch people work on that. So
yeah,
cool. Well, thank you so much, Alex. I'll see you soon.
All right. See you later, Griff.
Yeah.